Hi everyone, this is a summary that I'm going to explain you in detail one by one so that it will be easy for you to understand this module and it will be helpful for you in your examination. Please go through this summary step by step. I will explain you and I'll make you understand. First, introduction to the power supplies. A power supply unit, the PSU, is one of the most important parts of a computer. It takes electricity from your wall outlet and converts it into the right voltage that your computer components need. Without a good power supply, your computer wouldn't work properly or might even get damaged. Now, types of power supplies. There are different types of power supplies. Number one, ATX power supply. It is the most common type used in desktop computers. SFX power supply, that is smaller form factor used in compact PCs. Number third is modular power supply. It allows you to detach unused cables for better cable management. And number four is non-modular power supply. Here, all cables are permanently attached, so you cannot remove any cable in this kind of power supplies. Well, how to choose the right power supply for your device, for your computer? When selecting a power supply, consider the following things. Number one, wattage. How much power it can deliver. For example, 500 watt, 750 watt, or 1000 watt. Second is the efficiency rating. 80 plus certification like bronze, silver, gold, platinum, and titanium. Number three is connector. Ensure that it has enough cables for your motherboard, GPU, and the drives. Well, I will understand about installing a power supply. First, turn off and unplug the computer. Then open the case by removing the side panel. Number three step will be aligning the PCU with the case's mounting area, that is usually at the top or at the bottom of your device. Now secure it with screws to keep it in place. And at the end, connect the cable to the motherboard, that is the 24 pin, and the CPU, which is 4 by 8 pin, and GPU 6 by 8 pin, and with drivers, that is either SATA or Molex. Now, cooling systems in computers. We'll understand about it one by one. First of all, let's understand what is the cooling system in computers. Computers generate heat, and without power cooling, components can overheat and fail. There are two main types of cooling. Number one, very important, air cooling. Here, it is used in most of the devices when it is used with fans and heat sinks to dissipate the heat. Number two is CPU cooler. It is a fan attached to the processor to keep it cool. Number three, case fans. It helps circulate air inside the case. The second one is the liquid cooling. It uses liquid, usually the coolant, to absorb heat and transfer it away from the components. One is AIO, all-in-one coolers, that is pre-built liquid cooling system for the CPUs. And the second one is custom loop cooling, that is advanced setup which separates pumps, reservoirs, and radiators. Now we will understand about installing the cooling system in the CPU. First, apply thermal paste, which is a small amount on the CPU. Attach the heat sink and secure it with screws or clips. Then connect the fan to the motherboard CPU fan header. Now, in liquid cooling system, mount the radiator to the case, that is usually at the top or at the front. Second, attach the water block to the CPU with thermal paste. Then connect the pump to the motherboard, AIO pump or CPU fan heater. Now, I will explain you about a brief on the troubleshooting of the cooling and power supply. Sometimes the computer won't turn on. That means check the PSU connections and power switch. Overheating can be another reason, so ensure fans are spinning and airflow is not blocked. And one more thing, that loud noise may come. That means clean dust from fans or replace the faulty fans if required. Some of the maintenance tips to clean the dust regularly to prevent the overheating. Check for cables for wear and tear. In case there is any faulty cables, please replace it immediately. Now, monitor temperature. Using the software like HW monitor or fan speed. By properly installing and maintaining power supplies and cooling system, you can ensure your computer runs smoothly and lasts longer. Now I will summarize the motherboard topic. First of all, I will go through a brief introduction of the motherboard. The motherboard is the main circuit board on a computer. It connects all the components like CPU, RAM, storage, and GPU. Without a motherboard, the parts wouldn't be able to communicate with each other. Let me explain you the parts of motherboard. Number one is CPU socket, where the processor is installed. Number two is RAM slots, where it holds memory modules like DIMM slots. Number three is PCIe slots. It's for graphics card and expansion cards. Chipset is number four, that controls communication between the components. Number fifth is SATA ports, SATA. It connects hard drive and SSDs. Number six is M2 slots, that is for NVMe SSDs for faster storage. Number seven is power connectors, that is 24-pin main power and 4x8 pin CPU power. Number eight is BIOS or UEFI chip. It is the firmware that controls startup and settings. So let's understand about the types of motherboards. One is ATX, that is the standard size for full-size PCs. Number two is micro ATX, that is for smaller with fewer expansion slots. Number three is mini ITX, which is a very small, which is used in compact builds. You must be, aware that what kind of motherboard that you are choosing in terms of compatibility, RAM support, expansion slots, connectivity, etc. So I will brief you about all these things. First one is compatibility. Compatibility is where it must match the CPU socket. For example, AM4 is for AMD, LGA 1700 is for Intel. So ensure the compatibility is 100% accurate. Number two is RAM support. Check maximum capacity and speed. For example, DDR4 or DDR5. Number three is expansion slots. Your motherboard should have enough PCIe slots for your GPU and other cards. Now, number four is connectivity. USB ports, Wi-Fi, Ethernet adapters, slots, etc. should be there in the motherboard. Well, now installing the motherboard. This is very important. First of all, prepare the case. Install stand-offs like small screws that lift the board. Second, align the motherboard. Match screw holes with stand-offs. Number three, secure the board. Wear screws to fix it in place. Number four is connect power cables. That is 24-pin and CPU power. Number five, Install RAM, CPU, and storage before powering on. Now, BIOS and UEFI settings. First of all, the number one it comes is boot order. Set which drive the PC boots from. Number two, XMP/DOCP. It is enabled for faster RAM speed as we have discussed many a times. Number three is fan control. Adjust fan speeds for better cooling. I will also tell you about the motherboard troubleshooting. First of all, sometimes there will be no power. For that, please check the PSU and front panel connectors. Where there is no display, ensure GPU and RAM are seated properly in their slots. Number three, sometimes USB port not working. That means update the driver or check with the BIOS settings. A good motherboard ensures all components work together efficiently. Now, number three, storage devices, RAM, processor, CPU, printers, and troubleshooting methodology. Here, I will explain you first about the storage device. I will only summarize this. I have already explained everything in the chapter and in the module itself. So this is for your general information. I will ensure that I am delivering the bullet points to you. First of all, types of storage device. One is HDD, that is the hard disk drive, which is mechanical, slower, but cheaper. Now, the latest one is SSD, which is the solid state drive. It is faster, but has no moving parts. And then NVMe SSD. It is even faster than the SSDs, connects via M2 slots. Well, we are installing the storage like HDD and SSD, connect to SATA port and the power. For M2 SSDs, insert it to M2 slot and secure with a screw. Now, very important, that is RAM. RAM, that is random access memory, is the temporary storage for running the programs in your computer. Types of RAMs are generally DDR3, DDR4, DDR5. DDR stand for Dynamic Data Reader, which is faster with each generation. Installation. Installation of RAM. We have to align the notch and press into slots until it clicks. Once you hear a click sound, that means your RAM is into the slot perfectly placed. Now, processor, that is the CPU, which is the brain of your computer. Installation of the CPU. First, you have to lift the CPU socket lever, align the CPU, match the arrow, which will be on the CPU. अजय इसको हटा दो, इंस्टॉलेशन का फिर से बोलता हूँ. CPU फिर से बोल देता हूँ अजय, ठीक है, पूरा CPU हटा दो. Start. Now, the CPU processor, which is the brain of the computer. Installation is very simple. Lift the CPU socket lever, then align the CPU where it match the arrow, and then close the lever to secure it. Printer is a very important topic. The types of printer are inkjet, laser, and all-in-one printer. The connection could be with the USB, with the Wi-Fi, or with the Ethernet. Driver installation is very important. Without driver installation, the printer won't work on your device. For that, you have to use the manufacturer's software. Now, the troubleshooting methodology. First of all, identify the problem. For example, check if there is no power or no display. Second, check with the connections like cable, RAM, or GPU. Third is test the components like try the different RAM slots. Number 4 is update the driver or the BIOS. And number 5, replace faulty parts if required. Now, the power supply efficiency and voltage rails. Power supplies convert AC, that is the alternating current, from the wall into the DC direct current for computer components. They have different voltage rails. Number 1 is 3.3 volt, which is used for older components and some motherboard functions. 5 volt, it is used for power USB ports, some storage devices, and older hardware. And now 12 volts, the most important rail, used for CPU, GPU, and high power components. Now, guys, you may get question about the power supply efficiency and voltage rails. So ensure you go through this again and again and understand which power supply is used for which components. Now, a single rail PCU provides all power on one 12-volt line, while a multi-rail PSU splits power for the safety. High-end system benefits from single rail for maximum power delivery. Now, power supply safety features. First of all, over voltage protection, that is OVP. Here, the system shutdowns if voltage exceeds the safe limit. Now, the second one is under voltage protection, that is UVP. It prevents damage from low voltage. Over current protection is OCP. It stops excessive current flow. And short circuit protection, that is SCP, where it detects and prevents short circuit in your computer. Over power protection, that is OPP. It prevents PSU from exceeding its wattage limit. Now, calculating the power requirements. To choose the right PSU wattage, check CPU and GPU power consumption, that is the TDP readings. Then add power for RAM, drivers, and fans, that is from 50 to 100 watts. Now, fully modular PSU let you remove all cable for better airflow and the aesthetics. Now, another topic is power supply fan types. It is important. 120 mm fan is common, good balance for airflow and noise. 140 mm fan is larger, whiter, but found in higher end PSUs. Now, the third one is fanless PSU, where passive cooling, like no fan, but limited to low wattage builds. Now, I will explain you about the cooling system types in depth so that you will understand it clearly. First of all, air cooling enhancements. There is heat pipes, which are metal tubes filled with liquid that transfer heat efficiently. In dual tower coolings, larger heat sinks with multiple fans for extreme cooling. And now, downdraft coolings. It blows air directly into the motherboard, helping VRM coolings. Now, we'll understand about the liquid cooling variations. Number 1 is closed loop AIO coolers for pre-filled maintenance free. The second one is open loop cooling for custom setups with separate pumps, reservoirs, and radiators. The third one is external radiators, which is mounted outside the case for extreme cooling. I will brief you about the fan placement and the airflow optimizations as well. First one is front intake fan. It brings cool air into the case. The second one is rear or top exhaust fan, which remove the hot air. And the third one is positive airflow, which having more intake than the exhaust that reduces the dust inside your CPU. And the fourth one is negative airflow, which more exhaust than intake, that can increase dust buildup inside your CPU. Now, thermal paste application technique. Most common and effective is the PIA sized dot. The second one is X method, spreads paste evenly for larger CPUs. Then spread method, which is manually spreading with a card, risk of air bubbles. Power supply testing. Paperclip test is the first one where you can test the power supply. Jump the green wire to any black wire ground to check if the PCU turns on. Second is multimeter test. It measures voltage output for accuracy. And the third one is for load testing, while using a PSU tester or software to simulate high power draw. Now, advanced cooling solution. Phase change cooling is the first one. It's like a refrigerator, extremely powerful but are found very rare. Second one is liquid nitrogen LN2 cooling. It is used for extreme overclocking and it is not for daily use. Now the third one is Peltier cooling. It uses electric cooling plates but can cause condensation. Here I will tell you about the noise reduction techniques on the fan. First of all, fan speed control. Use BIOS or software to adjust the RPM of the fan. Then the second one is anti-vibration mounts. Reduce noise from spinning drives and fans. And the third one is sound dampening case panels. It absorbs noise for quieter operations. Well, here I will also tell you about the power supply and cooling myths that are debunked. First of all, we think about that higher wattage PSU waste electricity, which is false. They only deliver what is needed. Second is liquid cooling is always better than air. So it is not always true because high-end coolers can match the AIO. Third one is more fans always means better cooling. That is absolutely incorrect because if airflow isn't optimized, then whether you place 2 fans, 3 fans, it doesn't matter. So you have to optimize the airflow. Now, we also understand about the environmental considerations. Okay, first of all, 80 plus titanium PSUs, which is the most efficient. Up to 94%, it reduces the electricity waste. Second is low fan mode PSU. It stays silent under low loads. Now the third one is eco-friendly cooling. Eco-friendly cooling, it uses renewable energy for mining or server farms. So we'll also understand about the future trends in power and cooling. First one is GaN, that is gallium nitride PCUs, which is more efficient and smaller than silicon-based PSU. And the second one is smart cooling, which is AI-controlled fan that adjusts based on real-time temperature of your devices. For example, in case if the temperature in your devices exceeds, the cooling will also exceed accordingly. Now, number 3 is immersion cooling, that is submerging the PCs in non-conductive fluid for extreme cooling. Well, now we will just brief you more about the motherboard PSB layers and the build quality. In motherboard, there are 4 layers PCBs like budget boards adequate for basic use. 6-layer PCBs plus, that is for high-end boards, better signal integrity for overclocking. Now, military-grade components, which is for high durability, for example, Japanese capacitors. Nowadays, brands like Lenovo are coming with military-grade testing components in their laptops for higher durability of the devices. Now, expansion slots and their uses. PCIe X16, it is for graphic cards, which is for full bandwidth. PCIe X8 by X4 for NVMe editors, sound cards, or captured cards. Number 3 is PCI Legacy, that is older standard, which is rarely used today. Now, I will tell you about the chipset difference. It is very important and you have to understand this one by one. You may get questions on this in your examination. Also, you may face questions in the interviews as well. Let's get into this on depth. Chipset differences in Intel and AMD. Intel chipset, for example, 2790, B760, and H710. First is the Z series, which is called Z series as well. It is overclocking and have multiple PCI lanes. Second one is B series, which is having mid-range and have limited overclocking. Now the H series are in budget and have no overclocking. Now let's come to the AMD chipsets. For example, X670, B650, and A620. Here, number 1 is X series, which has high-end overclocking support. The second one is B series, having the mid-range, some overclocking is there. And the A series is into the budget and have no overclocking. VRM, that is voltage regulator module, which I am going to brief you one by one. Number 1 is phases. More phases is equal to smoother power delivery, which is important for overclocking. Now, the second one is MOSFET. It is for transistors that regulates the voltage. Number 3, it heat sinks. It keeps the VRM cool under load. Now, let's understand compare, in fact, bias and UEFI. Legacy bias, which is older, limited to 2.1 TB drives. UEFI is modern, that support fast boot, larger drives, and mouse controls. Now we'll understand about the motherboard connectivity options. First of all, the USB-C, that is Thunderbolt 3x4, which has high-speed data and video. Number 2 is Wi-Fi 6E/7, which is the latest Wi-Fi standard. Number 3 is 2.5G by 10G Ethernet, which has faster than standard gigabyte. Okay, now we will understand about the onboard buttons and the debug features. First of all, power reset button. It is helpful for test benches. Second is post-boot display, which shows error codes during the reboot. Third is clear CMO button, which reset the BIOS without removing the battery. Okay, now we'll understand about the motherboard form factor beyond the ATX. First of all, eATX is the first one. It is extra large for the workstations. DTX, which is rare between the micro ATX and mini ITX. And the third one is STX, which is mini XTX, which is ultra compact and smaller and tiny than the mini ITX. Okay, now we will understand about the multi-GPU support, that is SLI Crossfire. SLI, which is NVIDIA, it is dead and no longer supported. Second one is Crossfire by AMD. It is mostly phased out. And the third one is modern alternative, that is direct storage for GPU compute task. Now we'll understand about the motherboard RGB and aesthetics. eRGB headers is for addressable RGB strips. OLED displays where some high-end boards show temperature statistics. Server versus consumer motherboards. Now, server boards, it supports ECC RAM and multiple CPU, and consumer board focuses on gaming and overclocking. Future of motherboard are coming nowadays, which is PCIe 5.0 and 6.0 for faster lanes for GPU storage, integrated AI processor for smart power management. Now, the storage device like NVMe versus SATA SSDs. NVMe is used for PCI lanes, which is faster up to 7000 Mbps. SATA is limited to 600 Mbps. Hybrid drive. It combines SSD caching with HDD storage, which is faster than HDD alone. What is Optane memory from Intel? Well, it acts as a cache to accelerate the HDD, which is discontinued but still in use somewhere. Now, RAID configuration. I've already explained it in the module. I'm explaining it one by one here. Number one is RAID O, which is stripping, fast but no redundancy. RAID 1 is the mirroring, that is the duplicate data, and RAID 5 is parity, that balances of speed and safety. I will also tell you about a brief differences between DDR4 and DDR5. DDR5 is having the higher bandwidth, and on-die ECC, it is better for future proofing. ECC versus non-ECC RAM. ECC RAM is for error connection, used in servers mainly, and non-ECC is the standard consumer RAM. Now, multi-core versus single thread performance in the CPU. First one is gaming. It prefers high speed core speed. अजय फिर से करते हैं और एक बार बोलता हूँ ये multi-core का. Multi-core versus single thread performance in the CPU. Number one is gaming. It prefers high single core speed. The second one is workstation, which is for benefit for more courses. CPU cache, that is L1, L2, and L3. L1 is the fastest and the smallest per core. L2 is shared between cores, and the L3 is the larger one. Overclocking safety. First of all, voltage limit. Too high voltage can damage the CPU. And the thermal throttling. Thermal throttling is where the CPU slows down if too hot. Now, a small and brief differences between the laser and the inkjet printers. In laser, more expensive upfront and cheaper per page. And in inkjet, it is cheaper upfront, but the ink is very costly. 3D printing basics. In 3D printing basics, number one is FDM, which is plastics extrusion, which is most common. And the second one is resin, which is SLA and DLP, high detail used in dentistry and jewelries. Now, I will end up this with various simple hardware diagnostic tools that I'm going to mention you. First of all, MEM Test 86, it tests the RAM errors. Crystal Disk Info, it checks the SSD and HDD health. Now, common post deep codes. If there is one beep, that is the AMI bias, that means it is a normal boot. And if there is a continuous beep, that means there could be a RAM failure. Now, it is software versus the hardware issues. Blue screen, that is BSOD, which I have already explained in the module. It is always due to often driver-related issues. If there is no power, it is likely an issue with the PSU or a motherboard issue. So the advanced repair techniques here is to replace the SMD components, which requires a soldering skills. Number two is BGA reballing, which is fixing CPU or GPU solder connections. Well, thank you very much. As I explained this summary of the module 2, but by understanding these components and troubleshooting steps, you can build, maintain, and fix the computer effectively. So guys, please go through this module more than once, or if it is required, you can go through twice or thrice to understand this module bit by bit, and you will be getting a detailed summary of the computer hardware, installations, motherboard, storage, RAM, CPU, printers, and at last, the troubleshooting methodology. Thank you very much for going through this topic summary, and we will see you on the next topic. Till then, have a great day. Bye.